So let's talk about the scientific method. So one of the big overarching themes for this year's chemistry is I want you to get to start thinking scientifically. I want you to think like, be attentive to observations. And then I want you to, once you have those observations and you start seeing things, you start asking yourself questions like, well, why is it doing this? And what would happen if this happened? Or what would happen if this happened? And it's really just promoting your thinking rather than just seeing it and then going squirrel, look in the other direction. You actually start thinking about it. And that's what I want you guys to learn how to do this year, is to think scientifically. So the scientific method that you guys have, it starts with observations. It starts by taking the obvious, what you see, and asking a question, turning that question into a statement. And the statement is your hypothesis, right? And then once you kind of make your statement, you can take that and say, well, let's test this. Is this always true in all these circumstances, or within these circumstances, is this always true? And then you have your experiments. And then if that is always happening and is consistently every single time you have, this experiment is going to guarantee this result, and it always is happening, you can form a theory. So that is our method of thinking. We go from observations, hypothesis, we test it with experiments, and then go to our theory. So what happens is I'm going to draw something. Hopefully my pen works. Everyone knows how much I hated my pen last year. All right, so let me turn off the arrow. So right here, if I go, this is my O, and then we go to our hypothesis, right? Then we go to our experiments, right? Is everybody seeing this? And then we go to our theory. So what happens if we don't quite ever make it to our theory because our experiments don't prove our theory correct? We have to go back up to our hypothesis, okay? And then the same thing, if our experiments don't prove true, or if we go back to our hypothesis. So we never really would make it to a theory, but say we think that something is going to be a theory, and then one thing shoots it in the foot, and we have to go back and restart all the way over. So this is kind of your train of thought. So let's look at these examples. So identify below each of the following as an observation, hypothesis, or an experiment. So the statement, drinking coffee at night keeps me awake, what would that be? That's right, that would be observation. Okay? As a theory, after a theory is tested and everyone finds it to be the same, doesn't it become a law? Yes. But, under what circumstances that law have to go back to a hypothesis? I mean, because we talk about, lots of people will talk about natural selection as being a law, but it is not a law. It is more of a hypothesis that's never been fully tested because we can't test it, right? So gravity, yes, but there are certain conditions that we have forced that might not be completely natural that counter some of these things. And that's a little bit more of the physics side of things. That I am not a physicist, I'll tell you that right now. I'm so far from a physicist. But laws, those types of laws seem to be broken in labs under weird conditions. And, to be able to explain those things I took, a year of something called physical chemistry, and I passed, okay? I'll be honest with you, I struggled through it, and I graduated. I did okay, but when you start doing PChem, it's not a lot of fun, unless you like the physical side of things, and some people really would. Yeah. All right, so that would be drinking coffee at night keeps me awake. observations. So if I stop drinking coffee in the afternoon, I will be able to sleep better at night. What would that be? That's right, that would be our hypothesis. It is proposing something. It is proposing a statement, okay? I will try drinking coffee only in the morning, okay? And that would be the experiment. Good job. So these are like, this is going to be an example of what a question on a test might show up. You're going to see something, you're going to be like, oh, how do I make how do I make these things work? So you're going to have to go, is this an observation, hypothesis, or an experiment? Okay. All right. Let's try it again. So we're going to label these observation O, hypothesis H, and experiment E. So today I placed 2 tomato seedlings in the garden and 2 more in a closet. I will give all the plants the same amount of water and fertilizer. Which one? What is that one? That's right. That is the experiment. And when we were talking about an experiment, and we talked about this in biology, we have something called dependent variables. And I'm going to type this out because otherwise it might get a little. We have dependent variables and independent variables. And I'll push enter here in a second. There we go. Those are the 2 types of variables. What is a dependent variable? Can somebody tell me what a dependent variable is? Does the dependent variable change? That's right, the dependent variables can change. Yes. So those are ones like the dependent variables are the ones that are affected when you make a change in the experiment. Okay? Depends on what, that's right, Allie. And independent variables are the ones that you have control over. Okay? So the dependent ones, like your kids are like, for me, you guys don't have kids, but you are dependent on your parents. You kind of have to do what your parents do. So you're going to change with whatever your parents are doing. Okay? You are not independent yet. Okay, so after 50 days, the tomato plants in the garden are 3 feet high with green leaves. The plant in the closet is 8 inches tall and yellow. What would that be? That would be observation. Okay. So what would the last statement be? Tomato plants need sunlight to grow. Hypothesis. That's right. Now that's probably more at this stage a theory, or not, a theory or a law, because we know that plants need sunlight to grow. So it's not just a hypothesis at this point. It could be a theory. It could actually be a law. Okay. So, but you guys get the gist of what I'm trying to have you and how I want you guys to think. Okay. We have observations, we have hypothesis, we have the experiment and whatnot. Okay. All right, so I think some of you like Sherlock Holmes, but we have the scandal in Bohemia. Sherlock Holmes receives a mysterious note. He states, I have no data yet. It is a capital mistake to theorize before one has data. Insensibly, one begins to twist facts to suit their theories instead of theories to suit facts. What do you think Sherlock means? You guys can put this in the box. All right, Zethan, what is evidence? What is evidence, Ethan? Yep, that's right. So when we are talking about Sherlock Holmes, he has a strong sense Hopefully this works. That's right. Do we see this in life pretty much all the time, don't we? I mean, just there's so many people that just throw out all this data and say, well, this is how it is. And it's like, well, what are the facts? So you need to have a strong sense of O, or observation, okay, when you are studying your data. And data is the key word here, okay? Your observations are equivalent to your data, because the more data you collect, the more observations you are seeing. Yeah. Let's see, that if you make a theory without data, it can be whatever you want. If you make a theory with data, it will be correct and not biased. Perfect. Yeah. So let's see, what did Lachlan say? Without data, people begin to make up facts to see what they want to hear rather than using facts to find out the actual truth. Yep. So I mean, you must base theories on facts, or your theories will be wrong. That's right. So, we do have a natural bias and a lean towards certain ways, but let's look at the facts. And if some of you were with me in biology last year when we were talking about creation versus evolution, and just so much of the scientific fact that's in the secular world is not based on fact. It's just they take these things and it's not necessarily the truth. And so it's something, it's hard to think outside the box, yes. So, and it's not, we're not necessarily thinking outside of the box. I mean, these are all human behaviors, right, that we have to deal with. So when we make our data and our observations, it has to be what we see. It's not like, well, I think I might have seen it turn blue. Well, it's like you either saw it turn blue or it didn't turn blue. Okay? If it turned blue, then we need to write that information down. And there's something called brain games. I don't know if you guys have ever heard of brain games. And they took about a group of people and they set up a fake mugging, and these detectives came in and interviewed all these people, and they all came up with these random things like, well, I think it was a white coat. No, I think it was a red coat. And it was like, so our brain fills in gaps. And so it's very important to be paying attention, to have that strong observations. And then the next stage, once you have those observations, is you write it down. And that's your data in your labs. Okay, and that's why it's important to write down your data. Okay. Okay, question for you. If experimental results do not support your hypothesis, what should you do? Should you pretend that the experimental results support your hypothesis? Should you write another hypothesis or do more experiments? Let's see, B's and C's. Okay, a lot of people are saying B or C. So if you're already doing experimental results that don't support your hypothesis, so why would you change your experiment and do more experiments to make it so your hypothesis works? That's what we were just talking about, okay? So we can tweak things to make it work, or we can change. If you're going to do your experiment is going to be set, and then you go back and you change your hypothesis. Okay, then you can prove your hypothesis with that set of data. If you change your experiments, you have to change your hypothesis also, but you don't change your experiment and do more experiments expecting the same results. Yeah. Couldn't one experiment go? Yep. So that's why we do multiple experiments. So if you're doing whether you're weighing something, if you're going to weigh something once and you get 6.3 grams, right? And then you're kind of like, okay, well, it's 6.3 grams. Well, what if you weigh it again and it weighs 3.6 grams? You know, was it the scale? Did you read it backwards? And so you want to make sure you can either throw out the high and low number and average everything in between, or you would measure it maybe 5, 6, 7 times, depending on how strong of a number you want. And you weigh it over and over and over until you know. It's kind of like when you're counting, you know, something like if you're trying to share candy with your siblings, right? And you kind of split it in half and you go 1, 2, 1, 2, 1, 2, and all of a sudden you think that you guys have equal numbers. Never. You're going to make sure it's split evenly, right? You're not going to want to make sure that your brother or your sister has one more piece of candy than you. Okay. All right. So ways to succeed today. It's all mine. What is this? Share your speak. Right? That's right. I have teenage kids, so I have, like I said, I have that 15-year-old and an almost 14-year-old who can get along really well or fight like cats and dogs. So ways to succeed in my class. I want you guys to, again, take your notes, lab book, composition book, okay? Not required, but strongly suggested. Follow a schedule that I have posted. And I know that some people really appreciated this last year. I like doing it this way because it kind of is like, okay, I know how to think about these things. Here's my schedule. I'll get to it in just a second. Turn your homework in on time. Okay, I really want you guys to think about, you know, make sure to get your homework in on time. Let's see, Monday's class, everything will be due 11:59 Eastern time on Sunday night. So you have class Monday morning, you have all week long, and the weekend, right, to turn all your stuff in, and Sunday night, 11:59 Eastern time. So let's see, Kendall and Tia, I think that's how you say your name. Give me a thumbs up if I said it wrong or right. You guys are on West Coast time, so you guys have to think about turning things in at 8:59, Kendall. 8:59 is when it's due. Okay, not 9 p.m. 9 p.m. would be 1 minute late. Okay, so, and then do your reviews in the book. And I did not bring the book with me today. It was just, I brought so much stuff with me anyways to teach. Sometimes the reviews at the end of the chapter will be required as homework. Other times, they're just for your own, you know, understanding. And I do think it's important to go through the comprehension checks also because he explains them in the book. And so if you're doing the comprehension checks and the reviews at the end of the chapter, that just kind of gives you a heads up when it comes time for the test. Some of those will be required, not all the time. Okay, so for this week, this is your homework for this week. Today, day 1, you can see right here. You guys had class today. You guys can go into PSL. You can download your homework if you want to today and you can get it done. Or you can spread it out over the week, however you want to do it. But this week you have class. You have to read chapter 1. And then I have something called the Crazy Measurement Lab. The Crazy Measurement Lab is basically learning how to do unit conversions and remembering, because I think a lot of you have already done math. You guys have already done conversions. You don't have your book or lab kit yet. Okay, Michaela, I will post chapter 1 today or tomorrow, probably tomorrow because I'm up in Nebraska today and I don't have my book with me. I will post chapter 1 so you have access to reading it, okay? The lab kit we do not need for this week, so don't worry about the lab kits. Mine should be shipped to me today or tomorrow, but they are starting to ship, thank goodness, because I was getting a little antsy. I was putting in some phone calls up to Home Science Tools and saying, hey, are they just sitting up in Montana, or are you guys going to send those out to me? So you guys should be getting your lab kits. What was on back order should be getting in the mail this week. Okay, so crazy, if you already have yours, then you're on top of it, but we're not too worried about it. If you haven't ordered the lab kit yet, you can order it through Home Science Tools and type in MyFunScience Chemistry, and you will be able to order it, okay? I ordered it, but it hasn't been shipped. Yep, that's right. All right, so crazy measurement lab, again, that's unit conversions. And so like an example for the crazy measurement lab that I have for you is find the length of your pencil in miles. Okay, so you're going to be converting your length of your pencil to miles. So that's kind of just remembering. And then you're also going to use your scale if you haven't already got your scale yet. Hopefully you guys have got your scale. You're going to find the mass of a paper clip in tons, just one pencil in a mile. You're going to find how much does a paper clip weigh in tons. You will be able to use a calculator, of course. Okay. The world's big. Okay. And then there's a couple other ones. Area of a paper towel. And I said label your brand. You guys have to find the length of time you can hold your breath in years. It doesn't matter. You can tell me how much, what size of paperclip you used, Andrew. And you're going to need a temperature gauge. You guys are going to measure the temperature of your armpit. There you go. And you're going to find the volume of an Olympic-sized pool in milliliters. And I think that's pretty much it. So that's your science, your crazy measurement lab that you're going to do this week. And then you're going to do your comprehension checks. Again, those are not required, but suggested. And then you're going to do the scientific method worksheet. And that is just talking a little bit more about your independent variables, dependent variables, control groups, experimental groups, and whatnot. And then the very last page of the scientific method worksheet is you're going to write your own experiment. And it doesn't have to be long, but just follow the instructions. And it's called Experiment 4, and it's about spontaneous generation. So, and that is your homework for the week. And I'm done a little bit early today. Let's see, is there any questions that you guys want to ask me before we before we break? You can come on mic, raise your hand if you want to come on mic and ask the question too. Okay, yeah, that's a different class. I teach 2 different chemistry classes. Every week they're the exact same thing. So I'm a repeat. Monday and Tuesday, it's a repeat. When do we end? We end at 10:30 my time. So when is that? I don't know what time that is your time. 12:30? 12:30 Eastern. So you guys are from 11 to 12:30 every Monday. If you can't make it to a Monday class, you guys are welcome to come into my Tuesday class. And it is a different dynamic each class. Just the people are different, the questions are different, but they're kind of the same. But where are the comprehension checks? The comprehension checks are actually in the book as you're reading through. And basically, Dr. Weil will pose a question, and then he'll solve it for you in the comprehension checks, okay? And so the reading can get long, but it's easy reading. I don't feel like it's hard reading, okay? I think it's pretty straightforward the way that Dr. Weil writes. And the comprehension checks just kind of say, okay, what am I understanding or what am I not understanding? Okay. Next week, we have measurement and scientific notation. We'll go into mass and volume and talk about density. And let's see, is there any other questions? Okay. All right, you guys can go. Okay. You guys are free to go if you want to go. I'll hang out for a couple more minutes. Sometimes people are a little shy and they don't want to ask the questions. So bye, Ingrid. Thank you. Bye, Michaela. Bye, Sierra. All right. Bye then.